All right, when we talk about radicals, guys, it's the square root sign. All right, this little number right here in front is called the index. That's the root that they're talking about. So if you see just the square root sign, what's the little number that's there? Square root, what number would be there? A little 2, all right? You never will see that written. It's just understood. If you have the cube root, that's what number times itself 3 times gives you something. If you have the 4th root, that's what number times itself 4 times gives you something. All we're talking about today is square roots, all right? But understand that this is called the index, and you're going to need that when we get to rational exponents in a few days. You'll need to understand what that is. But when you have a radical and it says you have to simplify, from now on, you're always going to have to simplify. All right, these are a lot of words here. It says use a factor tree or you can extract perfect squares. Extract means to take out. Does anybody remember what a factor tree is? All right, if I was going to write the factors of 20, now you guys can do this either way. However your brain works is how you guys can do it. But what are the factors of 20? What times what gives me 20? 1 times 20, 5 times 4, and what else? 2 times 10. So if you were to use a factor tree, you could say 20, and then you guys would say what? 2 times 10, and then that breaks down into what? 2 times 5. So underneath your radical, you have a 2, and a 5. All right, if you were to use a factor tree, this would be the easiest way to do it. Anything that is a perfect square is a pair. Think about 2 times 2. What is 2 times 2? 4. What's the square root of 4? 2. So when you have a pair of something, you can circle it, and you can take it outside of the radical. You can write that pair. You write it 1 time out in front, and then what's left over underneath? The 5. Right there is the square root of 20 simplified. Anytime you just write out your factors, like from your factor tree, you write them all down underneath the radical, and then you can take out any of the pairs. You bring them out front. Now, another way, which is a way that I would like you guys to try to get to as we move on to bigger numbers and stuff like that, is the second method that says to extract perfect squares. You want to try to think of all the perfect squares. Do we know perfect squares? What's 1 squared? 1. What is 2 squared? 4. What's 3 squared? 9. 4 squared? 16. 5 squared? 25. Okay, we should know. You guys should know all the way up to 20. If you don't, that's okay. We need to practice it. But we should be able to say 6 squared is 36. 7 squared? 49. 8 squared? 64. 9 squared? 81. Good. 10 squared? All right. We made it up to 10. That's good. What's 11 squared? 121. 12. 144. 13. 169. 14. 196. It just flips. 15. 225. 16. What's 16? Do it real quick. What's 16? Okay. What's 17? 289. Some of you are like, what? It's okay. The ones above 15 are harder. And again, you don't have to memorize them. It's just nice to be familiar. You should 100% be familiar with 1 through 10. So if you are going to simplify this without using a factor tree, and you're going to say to yourself, okay, 20. 20 is 1 and 20, 2 and 10, 4 and 5. Which pair has a perfect square in it? 4 and 5. So you could say this is 4 times 5, and then you take the square root out. What is the square root of 4? 2. So I take that out, and I'm left with 2 square roots of 5. That is what we're going to practice doing today. If you have to practice using a factor tree, that's okay. But I want you guys to move towards being able to split it into perfect square and non-perfect squares. All right, so let's do some examples here. Think about 28. If I'm going to break down 28, I'm going to write down my radical. Think about a perfect square that's in 28 and a non-perfect square. What times what gives you 28? 7 and 4. All right, 1 and 28. 2 and 14. Nothing with 3. And then you have 4. So you have 4 times 7. Well, what's the perfect square that's stuck in there? What's the square root of 4? 2. So this becomes 2 square roots of 7. If you were going to do a factor tree, which again, some of you are going to have to do here at the beginning, that's okay. I'm going to break this down into 2 and 14, right? What does 14 break down into? 2 and 7. So if I were to write out my factors underneath my radical, I have a 2 times 2 times 7. Is there a pair that you can take out? A pair of 2s. So I'm going to take that 2, I'm going to put it outside, and the 7 stays in. Same answer. Just takes us a little bit longer. You guys got to practice this. Very important to practice. All right, we're going to do this 2 ways. We're going to do it with a factor tree and without a factor tree. I have a 2 on the outside here. We have to leave that on the outside for right now. But what is going to give me 48? Does anybody know the biggest perfect square that's in 48? 16. Very good, sir. 16 times what? 16 times 3? Good job. What is the square root of 16? 4. So watch what happens, guys. I'm going to take that 4 out. I'm going to put it up here. What do I do with the 2 that's already out in front and the 4 that I took out? I'm going to multiply it. So 2 times 4 gives me 8 square roots of 3. Some of you are like, wait, what? Did anybody think of something else that makes 48? Okay, 6 times 8. Good. I agree. 6 times 8. Are either of those perfect squares? No. So let's break that down a little bit. What can I break 6 up into? 3 times 2? What can I break 8 up into? 2 times 4? Okay. Now, did that help us at all? Let's think about it. Is there a perfect square now that you see? 4. All right, let's take that out. What's the perfect square that's in there? 2. Do you see a pair of numbers that are the same? God bless you. There's another 2, right? So I bring that out. What do I do with all those numbers that are on the outside? I multiply them. So I have 2 times 2 times 2. What is 2 times 2 times 2? 8. And then what stays on the inside? Square root of 3. So if you don't choose the biggest, that's okay. Sometimes it's not going to be evident. But break it down into 2 smaller numbers and then keep breaking those down. Anything that has a pair, you can circle it and bring it out. Very important. Yeah. Because what's the square root of 4? Because underneath the radical. Yep, because 2 times 2 is 4, and then the square root of 4 is 2. All right, so I already kind of did 48, so we'll skip that one. Let's do this one. All right, I have my 6 on the outside. That means whatever I take out, I'm going to multiply. So think about what we can break 45 into. 5 times 9. All right, that's probably the first thing that jumped into your all's brain. Well, what do you know about 9? It's a perfect square, isn't it? So I'm going to cross out the 9, and what am I bringing out? A 3. Well, what do I do with that 3 that I just took out? I'm going to multiply it by the number out in front, right? What is 6 times 3? 18. And then what's going to be left over inside? Square root of 5. Not all of you are going to do this the exact same way. Some of your brains just work a little differently, and that's fine. Yes, sir.
Why'd you put 3 at the top?
I just took it out. You can put it anywhere. If you wanted to put it out in front, you could. I was just showing that we took the square root of 9 out, and the square root of 9 is 3. All right, let's keep going. I want to say something right here. Write this down. A house times a house equals a bigger house. What I mean by that is if you have 2 numbers that are underneath a square root, you can multiply them together. If you have 2 numbers that are outside of a square root, you can multiply them together. You just can't combine the 2. You can't multiply something on the inside that's something on the outside. If you have 2 numbers that are underneath a square root, you can write them together. You can multiply them together. Same thing on the outside. You just can't combine the two. And then this example down here says when you multiply a square root by itself, you get the number without the square root. What that means is if I take the square root of 2 times the square root of 2, right? A house times a house is a bigger house. So I can rewrite that as the square root of 2 times 2. Well, what is 2 times 2? I get the square root of 4. And then what is the square root of 4? 2. Whenever you multiply a radical by the exact same radical, the radicals just cancel out. The square root of 5 times the square root of 5 is square root of 25, which is 5. So the square root of 7 times the square root of 7 is what number? Square root of 49, which is 7. If you multiply a radical by its exact same thing, the radicals just cancel out. So square root of 7 times the square root of 7 is just the whole number 7. Square root of 19 times the square root of 19. 19, that's it. Remember that. It's a good thing to remember. All right, so let's look at this. Anything on the inside you can multiply together. Anything on the outside you can multiply together. So I can multiply 5 times 2 and get what? 10. Then I can multiply anything on the inside. So 2 times 3 and get 6. Can I break down 6? Is there any perfect square that's stuck inside of 6? No. So just leave it. That's as slow as you can go. All right, look at number 6. Do I have 2 houses that I'm multiplying together? Yeah, so I'm just going to go ahead and rewrite them underneath one house. Instead of multiplying 33 times 11, guys, we're trying to break down. We're trying to simplify and make smaller. So let's think breaking down. Can I break down 11 into anything? Just 11 and 1, right? So I have 11. Can I break down 33? What times what gives me 33? 11 times 3. Okay. Now, when we visually write this down, do you guys see a pair of anything? Yeah, I see 2 11s. What's 11 times 11? 11 times 11 is 121. If I'm going to take the square root of 121, what's my answer? 11. So if you have a pair of something, you can circle it and say, oh, I have an 11 I'm going to bring outside. So now your simplified version is just 11 times the square root of 3. Anything that has a pair, you can bring it outside. Can you guys see that one? Yeah. What do you mean a big number? But that's, you're making it bigger. When you simplify it and break it, you want to make it smaller. You want to make it in its most simplest form. All right, if I look at number 7, some of you are going to see things one way, some of you are going to see another. Is there anything that jumps out at you about number 7? Okay, there's 2 5s underneath the radical. When you multiply the same radical by itself, what do you get? Think about this. If I multiply the square root of 5 times the square root of 5, it's the square root of what? 25, which equals what number? 5, right? Anything else jump out at you? What's the square root of 9? 3. What's your answer here? 15. Okay, good. Say you didn't see that. Some of you are like, what? I didn't even see that. That's fine. What did I tell you about houses times a house? A house times a house is just a bigger house. Write them all underneath the same square root. I have 5 times 5 times 9. When you have a pair underneath the same square root, what can we do? We can take it out. So I'm going to circle this, and I'm going to bring it outside. I already took it out. Now I look at what's left over there. Can I simplify the square root of 9? Yes. What is the square root of 9? 3. What is 5 times 3? 15. You do not want to multiply them all together. You think about, you're trying to make things smaller. You're trying to simplify. You're trying to break down, so you don't want to make your numbers bigger. And you'll start to see patterns, guys. We're not going to give you numbers that are just ginormous and you can't do. You don't have a calculator. We're going to just try and make you think a little bit. Don't make your life harder. Let's think about this one. What do you guys see? What's the perfect square? Good. Square root of 25 is 5. Good. Times. What can I break 45 into? 9 times 5. Perfect. Is there a perfect square in there? What is it? Good. Square root of 9 is 3. And then what do I do with the 5 that's on the outside and the 3 that I took out? You multiply. What's 5 times 3? 15. And then the square root of 5 just hangs out. The only way that you guys get better at this is by practicing. You can't just look at this and be like, oh, okay, I hate this, so I'm not going to do it anymore. You have to. The more you practice, the better it'll get, I promise. All right, just when you feel like you're getting the hang of stuff, and then you're like, oh, good, she's going to throw something else at us. We're almost done. All right, it says, if the index and the radicand are the same, what that means is the little number in front, this is a 2, and this is a 2. If it was the cube root and the cube root, the 6th root and the 6th root, this is the radicand. All right, if they are the same, you guys can add them together. If I gave you this problem, what would you guys tell me the answer is? 6x. All right, if I gave you this problem, what would you tell me the answer is? 6y. Okay. If I gave you this problem, can you combine those two? Why not? Because the letters aren't the same. The exact same thing goes for radicals, guys. Don't confuse this. Look at the last name. This is radical 5. This is radical 5. If they have the same radical, you can add them together. I have 2 of them, and I have 4 of them, which gives me a total of 6. So your answer here would be 6 square root of 5. Look at the last one. Look at this. Do they have the same radical? No. One is square root of 2, one is square root of 3. So can you combine those at all? No, this is it. That's as simple as you can make it. It's like saying 2x plus 2y. You would say, oh, you can't combine those. They're not the same. The exact same thing happens for radicals. This one, 2 square roots of 24 plus 4 square roots of 6. How it's written, do they have the same radicand? Do they have the same radical at the end? No. So you can't just combine them right now. But if you get a problem like this, 95% of the time, you're going to be able to add them after you simplify. So let's look at it for a second. What can I break 24 into? 6 and 4. Why'd you guys choose 6 and 4? I totally agree, but why? 4 is a perfect square. Good. What's another reason you might have chose 6 and 4? The other radical is a 6. If I'm telling you we're trying to get the radicals the same so we can add them, there's probably a clue in the problem to help you break down the one that you're trying to break down. So let's simplify before we try and add. Is there a perfect square underneath this first radical? Yeah. What's the square root of 4? 2. So I'm going to take this out. I'm going to put a 2. And then what do I do with the 2 out in front and the 2 I just took out? We're going to multiply. So this is 4 square root of 6 plus 4 square root of 6. Do they now have the same last name? Yes. If I have 4 of something and then I'm adding 4 more to it, how many total do I have? 8. And then what does our last name stay? Square root of 6. It's just like if they were x's and y's. And again, we've got to practice this. I'm going to be done in just a couple minutes and you guys can practice. All right, let's do the last few. All right, don't make number 9 harder than it is. Look at your problem. Do they both have the same last name? Right? They both have square root of 3. Can you say 8 minus 6? Yeah, what's 8 minus 6? 2, and then what's the last name? Square root of 3. That's it. We just did a problem exactly like this, but we'll do it again. Do they, as it's written, do they have the exact same last name? No, but let's see if we can help that out. What can I break 24 into? Good, 4 and 6. Again, we chose 4 and 6 because 4 is a perfect square, and this is a 6, so we'll probably, that'll be a clue. What is the square root of 4? So bring that out, good job. What do I do with the negative 2 and the 2? Multiply. So I have negative 4 square root of 6 minus 3 square root of 6. What is the last name going to stay? Square root of 6. Good. Write it down. What's negative 4 minus 3? Negative 7. Good. Okay, let's look at 11. How it's written. Do they have the exact same last name? No. All right, so let's see. Can we break down? Can we break down 5 or 3 and make them be the same? No. So is there anything we can do? That's it. If that case arises, you can just circle it. You can say simplify. You could rewrite it again and just show me that you can't do anything. Don't just leave it blank, because then I think you just skipped it. So if that is the case, just be like, it's already done, can't do anything else. However you want to let me know that, we're good. All right, number 12, and then we're done. Are those two the exact same numbers? No. Okay, so let's see if we can break them down. What can I break 28 into? Okay, 4 times 7, agreed. What about 63? 7 and 9, very good. Well, what is the square root of 4? 2, bring it out. So I have 2 square root of 7 minus, what's the square root of 9? So I have 3 square root of 7. Do they have the same last name now? Yeah, they sure do. So it's the square root of 7. And then what is 2 minus 3? Negative 1. You could write it like that, or you could write it just with a negative sign out in front.